Okay, am I audible?
Yes, sir.
Yes, sir.
Okay, so today I will start implementation view, chapter 5. Okay, so slide is visible.
Yes, sir.
Okay, so implementation view, see this view. Okay, so within implementation view, only one diagram is there, that is component diagram. Okay, so I will mainly discuss component diagram. So, so far diagram deals with conceptual entities. Okay, so far whatever diagrams we have discussed that deals with conceptual entities, like use case diagram, use cases, then class diagram, classes, objects. Okay, so those are conceptual entities. Okay, so class diagram represent a concept, an abstraction of item that fit into this category. Okay, state diagram represent a concept changes in the state of the object. Okay, so okay, now this component diagram deals with separate type of entities, that is a software component. A software component. It's not a conceptual type of thing, it's a real thing. Software component will be there.
একজন জয়েন হতে পারছে না।
Okay, so it's not a conceptual. Okay, so it's a 1 minute. So it's not a conceptual type of thing, it's a real thing. Software components. So the component diagram deals with that. Okay. Now it is an implementation diagram. Okay, so how we are implementing a software. It's a implementation diagram describes the different elements required for implementing a system. Okay, it is a structured diagrams, a type of diagram that depicts the elements of a specification that are irrespective of time. Okay, so it's a structural diagram, so it is not changing with time. Okay, it's a static type of diagram, it's not dynamic. Okay, now it is a modular part of a system. Okay, software components, it is a modular part of a system. So we can, as we know, we can divide a software into different modules. Okay, and each module may be a component. Okay, so it's a modular part of a system. A component resides in a computer, not in the mind of analyst. Okay, think about class. Class is present in the mind of the analyst, not in the computer. Okay, think about use cases. It's present in the mind of the analyst, not in the computer, but a component resides in the a component resides in the computer. Okay, a component provides interfaces with other components. So components, can interact with other components, and for that reason, it provides different types of interfaces. I have already discussed interfaces. So there are two types of interfaces. One is required interface, another is provided interface. So through these two types of interface, components are interacting with other components. Okay, so a component is an autonomous unit within a system. Autonomy means it can take its decision of its own. Okay, so in that case, it is autonomous. Okay, so a component is an autonomous unit within a system. Okay, so a component can be used to define software system of arbitrary size and complexity. Okay, so the components can be used to define software systems, okay, of arbitrary size and complexity. So these components means these diagrams or these components is useful for a very small size of software or maybe for a big size of software. Okay, so this is applicable for all types of software. Okay, UML component diagram enables to model the high-level software components and the interfaces to those components. Okay, so UML component diagram can model high-level software components, okay, and the interfaces through which these components interact with each other. Okay, important for component-based development. So if we can divide the software in terms of component, then we can develop that software component-wise. So this component diagram helps to develop a software, and that phenomena is known as component-based development, or that procedure is known as component-based development. Component and subsystem can be flexibly reused and replaced. First, I'm using this term, I am discussing this term reused. Suppose you have developed a component for any software, okay, and that component may be used for development of other software. Okay, so reused, okay, and replaced. As every components are autonomous, means one component is not going to affect other components if we keep the interfaces same. Okay, so we can replace one component keeping the interfaces same. Okay, so component can be replaced. Now, a dependency exists between two elements if changes to the definition of one element may causes changes to the other. Okay, so when we can say that two are dependent upon each other, if we change something in one, then that will affect other. In that case, we can say that two are dependent, two things are dependent. So if we can change in one and that will not affect the other, in that case, two things are independent. Okay, so if we change in one component and if that affects others, in that case, we can say that two components are dependent upon each other or dependency exists. Otherwise, dependency does not exist. Okay, component diagrams are often referred as varying diagrams. Okay, in some books, you can get varying diagrams. Okay, so component diagrams are often referred to as varying diagrams. Okay, the varying of components can be represented on diagrams by means of components and dependencies between them. Okay, so now there may be various types of components: deployment components, work product component, execution components. Okay, so inside a diagram, component diagram, there may be various types of components, or we can categorize components into these parts. Okay. Now, component in UML version 2. Okay. So it is written that modular unit with well-defined interfaces that is replaceable within its environment. that is component according to UML version number 2. Okay, and as I have already told that it is autonomous. Autonomous unit within a system has one or more provided and required interfaces. So there will be few interfaces. Some interfaces may be provided interface, some interfaces are required interface. Okay, the internal are hidden and inaccessible. We cannot access internal of the component. We can only interact through interfaces. Okay, the components are encapsulated. Okay, so it's within a capsule. We cannot see what is inside of the capsule. Okay, so it's a encapsulated. Okay, its dependencies are designed such that it can be treated as independently as possible. Okay, as components are interacting with each other, one component can do its work with the help of other component. So dependencies are there, but we should design component in such a manner so that they become as independent as possible. Okay, so that we can replace one component, keeping the interface same. We don't have to think about other components. Okay. So case study. We have to build a software. Development of an application collecting students' opinion about course. So you have to build a software. This software will collect student opinion regarding a course. Okay. So
Hello.
जॉर्ड मुन्ना खत्म हो गया क्या? क्लास खत्म हो गया।
टीम क्या हुआ सर, चले गए?
मुझे क्या पता है।
कोई क्लास कर रहा है?
अच्छा, इसका मतलब सर रियली में गायब है। मुझे तो लग रहा था मेरा ही कनेक्शन लॉस्ट हो जा रहा है बार बार।
सस्पेंडेड नाउ।
क्या?
अरे 33 से स्लाइड था भाई, खत्म हो गया क्या?
सर 2 नंबर क्या है?
नहीं
Am I audible, please?
गायब चंदन।
प्रियव्रत क्लास क्या हुआ?
खत्म हो गया आज। सो जा जाके।
पता नहीं, साइड चले गए।
सीआर को बोलो पता करने के लिए।
कितना पता करेगा सीन।
सो गए, सो जा मासूम, सो जा सो जा।
राजू पहले सोएगा तो नींद आएगा सबको रे।
ज्यादा खा लिया क्या राजू आज?
जवान ज्यादा खुल रहा है।
एक्स्ट्रा डाइट लिए थे सुबह में, इसीलिए बोल।
लग रहा है एग्जाम अच्छा जा रहा है इसलिए।
हाँ,
मधु है।
मधुमेह पढ़ रहा है, उसको डिस्टर्ब
मैं
मत
ड्यूटी
करो।
कर रहा
तो इसको डिस्टर्ब क्या कर रहा है भाई, पढ़ रहा है, छोड़ दो।
हूँ। मैं को डिस्टर्ब मत, बेचारा अपना काम कर रहा है।
सब लेफ्ट हो जाते हैं, सर बुला लेंगे नहीं तो, मतलब बुला लेंगे अगर सर आ गए तो। क्या
मधुमेह है ना, ग्रुप में मैसेज करेगा।
सर को सरप्राइज देना चाहते हो? चलो ये भी सही है।